Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on amplifier. On my previous video, I have described how a Class B, which is also known as push-pull amplifier, actually works. I'm not sure whether are you able to recall there is one issue on Class B amplifier, which is the crossover. This video, I'm going to discuss what are the ways that we can actually solve the crossover, or sometimes known as notch distortion, in the Class B push-pull amplifier. Okay, in fact, we use this Class AB amplifier to describe this process to solve the crossover or notch distortion in Class B. So this will be the objective of this video. This will be the part 6 series discussion on amplifier. So guys, if you're keen to know more about amplifier, such as Class A, Class B, okay, very soon I will also do Class C. Okay, so if you're keen, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on amplifier. This is my email. If you have any question regards on this discussion, please drop me an email. Before I continue, I'd like to urge you guys to support this channel by pressing the like and also the subscribe button. Please also turn on your notification bell in order to receive more information from this channel. Guys, once again, thank you so much for your strong support. Okay, firstly, let me do a very quick discussion how this Class B amplifier actually work in order to make this whole discussion fruitful. Okay, for example, when there is no signal at the input, okay, which means that at the input I have nothing. Okay, what happened here is basically both the transistor 1 and also transistor 2 will be off. Okay, because there is nothing that appear at the input signal, both the transistor will be off, and because the transistor is off, there won't be any collector current flowing, as is illustrated over here. During the positive half cycle, okay, which is this part here, this is the positive half cycle at the input signal. What happened here is basically this NPN transistor will be on. Because this is a NPN, anything that is positive over here, okay, this transistor will be on. As this is a PNP transistor, anything that is negative over here, the transistor will be on. For this case, because this is a positive half cycle, therefore transistor 1 will be on, while transistor 2 will be off. This transistor will be on, this transistor will be off, and therefore the collector current will only flow through TR1, but not to TR2. Okay, which means that the collector current will flow through TR1, and basically this is what we call a push effect. You can see that we push the current to the load. Next, during the negative cycle of the input signal, okay, so negative half cycle will be here. Okay, what happened here is basically the TR2, transistor 2 will be on, while TR1 will be off. This time round, this PNP transistor will be on, this NPN transistor will be off, because at the input is actually a negative signal. So when this happens here, the collector current will only flow through TR2, but not to TR1. In this case here, you can see that the collector current will be pulled into TR2. So this is how they actually get the name of push and also pull amplifier. Okay, so with this, I think you have a better idea how a Class B amplifier actually works. I'm not sure whether you see a potential issue here. Okay, so what happened here is basically for a transistor, you need to have a 0.7 bias to on. Okay, anything that you have less than 0.7, the transistor will not be on, and this become a potential issue which we need to address for this video. Let me give you an example, okay, rather than by words. Okay, for example, this time round, we have an input signal of 1 volt peak. Okay, let's forget about RMS value, okay, in order to make the discussion easier. Okay, so let's, like what I mentioned, let's forget about VP or RMS value. Okay, so imagine this is 1 volt signal here, and I need to have a 0.7, okay, in order to bias this transistor. Okay, imagine that you can, you can imagine that most of the signal will not be on. Okay, basically, this red line here basically will be 0.7 volt. Anything that's underneath will not be on, and basically anything above it will be on. So therefore, you can imagine that very small portion of the input signal will be appeared at the load side. Okay, so this I have illustrated over here. Okay, so basically for an ideal, you can actually see the whole input signal amplified. However, for this case, because of the bias of the transistor, most of them will not be able to on. Okay, because this is a 1 volt signal. Okay, you can imagine only this part will be on. So basically, in terms of this idea, a very small so-called hum or lump will be able to generate at the positive half cycle. Same as for the negative half cycle here. Okay, very small portion, okay, will be appearing at the load, and this become a potential issue. If I put these two, okay, combined together, okay, this will be the amplifier. You can see that this is a very large crossover issue that we need to resolve. Okay, so basically this is the objective. How can we actually resolve the crossover issue? Okay, let me give you another example in order to make this discussion on crossover issue much more clear. Let's say now instead of 1 volt, I actually has 10 volt. Okay, you can imagine that 10 volt, I actually has most of the signal will be able to appear at the output of the load. Okay, imagine this, because this is a much bigger input signal. Earlier on is 1 volt, so now I change to 10 volt. As you can visualize that most of the portion will be able to appear at the load side. Okay, so basically this will be the outcome. Basically, you can see that a small portion will be the so-called crossover issue here. Okay, again, okay, same for the positive and negative up cycle. I put them together. You can see that you still have some issue on crossover. So in short, over here, the bigger the input signal, okay, the minimum crossover issue you have, as you can see from the illustration of 1 volt and also 10 volt. Okay, so therefore, how can we actually resolve this crossover issue? The first method, okay, basically is to add a resistor. Okay, once we add a resistor, somehow we call this a class AB amplifier. So let's take a close look. How can we actually resolve the crossover? Okay, so we need to do a proper design on the value of the resistor. Okay, so imagine this again. Okay, we need to ensure that there will be a 0.7 drop over here, 0.7 volt drop over here. This voltage will ensure the transistor will be able to bias. So we need to proper design the value of the resistor so as to ensure that the voltage drop will be 0.7, and this 0.7 will bias this transistor. It will be the same for the negative half cycle over here. We need to do a proper design on the value of the resistor, and hence because of this, then the transistor will be biased. However, there's one potential issue. Okay, you know that resistor is subject to thermal noise, and basically this make this resistor value unpredictable. For example, here, so hence it may be some challenge to ensure that this voltage here will be continuous 0.7 volt drop. Let's say because of some heat issue, because of some other unforeseen issue, I can't really guarantee that the voltage drop will be constant at 0.7 volt. However, this is also one of the methods to resolve the crossover issue. Definitely, I cannot 100% resolve this crossover issue, but this over here shows some of the form how we can actually resolve the crossover issue. So this is the first method, we add a resistor. Another method is simply by adding a diode over here. Okay, basically we add a pair of diode. Basically, the diode has a characteristic of 0.7. Basically, this will ensure the transistor will be able to bias. And with this, you can imagine the crossover issue. We will more or less eliminate away this crossover issue. And basically over here, you can imagine that the output here will have a very nice positive half cycle and also a negative up cycle. So with this, okay, again, you can see that basically we make use of this class AB amplifier to resolve the class B issue of crossover. So again, if you find this video helpful, okay, please consider to like this video and also subscribe to this channel. With this, I'd like to end my discussion. Again, please help to like and subscribe. Thank you so much, and I hope to see you guys soon. Bye for now. Thank you.